We next look at Chapter 5 of Volume 1, Algebraic Expressions. Algebraic expressions are going to be made up of variables, where a variable represents a letter, and specific numbers, which are represented by constants. Then we combine these with our various operations. So these down here are examples of algebraic expressions. Then most of the discussion in this chapter is going to deal with polynomials. Here's our definition of polynomials. The polynomials are made up of terms. Terms are things that are added together. Since the coefficients can be negative, this is actually added and subtracted, where we have a coefficient in the front, the variable x, and then a power. If we just have one term, it's called a monomial. If we have two terms, it's called a binomial. And if we have three terms, it's called a trinomial. All of these together are called polynomials. So a polynomial can be a monomial, a binomial, a trinomial, or more terms. Then they deal with the degree. So again, take a look at this definition. So if we have the monomial 4x squared, the trinomial x squared plus 5x plus 6, the binomial x squared minus 16, we look for the highest power of the exponent in the whole problem. So the degree of all three of these turns out to be 2. When you're dealing with a constant other than 0, you can think of it as minus 8x to the 0 power, so a constant is considered to have degree of 0. And as they discuss here, 0 itself has no degree. We're going to next look at adding and subtracting polynomials. So if they ask us to define the sum of polynomials, what we do is, just like when we were combining like terms, if there's nothing in the front of a grouping symbol, we like to put a 1. And then we like to use our mnemonic for multiplying this stuff out that parallels the multiplication and division rule. So 1 times this is minus 2x squared. 1 times this is positive 4x. 1 times this is 5x squared. And 1 times this is minus 7x. Combining these then, we use money. So if we owe $2 and have $5, we have 3, so it's 3x squared. And if we have $4 and owe $7, then we owe $3. So the answer turns out to be 3x squared minus 3x. Looking at a subtraction problem, again, we put our 1 in the front. So this is 1 times 3 is 3x squared minus 2x plus 4. So the 1 just leaves it stay the same. The minus 1 becomes minus 2x squared, and minus 1 times 6 becomes minus 6x. Then again, we go to our money situation. So 3 take away 2 is ordinary subtraction. So technically, we can have two positives or subtraction, so we can do those direct without technically thinking of money. Or we can think of it as having 3 and owing 2, so it turns out to be 1. Then we go to our x coefficients, owe $2, owe $6, so owe 8. And then there's just the constant 4 left over. Let's go over and take a look at these on our calculator. So when we put these into our calculator with the parentheses around the first 2 and a parentheses around the second 2, and we press enter, our calculator drops the parentheses and comes up with the answer 3x squared minus 3x. On the second one where we're doing subtraction, again, when we press enter, the first set of parentheses are dropped, but the second parentheses stay because of the negative sign. And again, we come up with the same answer that we came up with when we did the problem manually. And this screen over here shows that what's going on. Okay, let's go on to the next page. So we're next going to discuss what they like to call the FOIL technique, where when you have to multiply a polynomial or a binomial times a binomial, we end up taking the first, a times c. We end up taking the outer, a times d. Then we end up taking the inner, b times c. And then we end up taking the last, b times d. To show why this is true, we go through and use the distributive property twice. Now, when we're looking at this scratch pad that shows what's going on, we cannot just put these in directly. We have to use the expand command to do this. So the first thing we start off with to show why this is true, we take a binomial a plus b times e. So we're using the distributive property to get ae plus be. Then we go down to here and we substitute in for the e the c plus d. Then again we use the expand command and it turns out to have the same answer as if we put the expand command in directly. So this is showing why the FOIL technique works. Let's go ahead and take a look at a little bit of this on our scratch pad. So we'll go over to here and we'll go to our scratch pad. And so the first one, to get the expand, we'll go to menu, we'll go to algebra, we'll go to expand. Then we'll have to put in a set of nested parentheses. So when we put in a set of nested parentheses, we put in then A, add B. We want to make this times E, so we're going to move over and we're going to put the E in, and then we'll press enter. And then we end up with the same answer that we had over in the scratch pad. Again, you can finish this problem out. Let's just go to the last part of this. So we'll bring up menu, we'll bring up algebra, we'll bring up the expand command, which is 3. We'll put in the parentheses, then we'll put in A plus B. We'll go down the other side of the parentheses. Just to be on the safe side, we'll put in a times sign instead of trying to use an implied times sign. Then we'll put in the C plus D. Press enter, and we will end up with our traditional FOIL technique. Let's go back to our scratchpad screen in our book, and you see that the first one and the last one is what we typed in. Let's flip to the next page. So when we multiply polynomials, what we like to do is we like to multiply all the terms in the first factor times the second factor. We like to use the distributive expand mnemonic to remove the parentheses and, if possible, combine like terms. Here again it shows us doing this with some examples, and we're actually showing it work out. If we were just following this rule, we would go directly down to here. We'd go 2 times 3 is 6x to the 4th. This one times the second one, so 2 times minus 5 is minus 10, and we have the x. Then we go to the next term in the first one and take it times everything, so 1 times 3 is 3x squared, and 1 times minus 5 is minus 5. Then we put things in what they call standard form, which is descending order, so it becomes 6x to the 4th plus 3x cubed minus 10x minus 5. This with the right and left distributive property was showing why it works. But once we do one problem or so with why it works, we'd like to just go ahead and use this multiplying polynomial to get our answer. Let's take a look at another problem here using this technique. So the 3 times 2 is equal to 6x squared. The first times, okay, the second one here is equal to positive 3x. Then taking this times everything, minus 4 times 2 is minus 8x, and minus 4 times positive 1 is negative 4. Then the two in the middle, when these are the same degree, will combine to be 6x squared minus 5x minus 4. When we have different terms here, then we just get them in different order. The things do not combine. Next, go over and look at our calculator. So we'll go to our home screen. Then we'll go to our recent doc. Then we'll move over so we can see this screen. And we can see that when we expand this, we end up with the same answer that we got over here. And when we expand the second one, we end up with the same answer that we got for the B part of our example. Turning to the next page, we see we have the special products formula. So the squares of a binomial with a plus or a minus, we square the first term, we double the 2, and we square the last. With the minus sign, the same thing except that we have a negative in the middle. When we have the sum and difference of a binomial, where one's plus and one's minus, the middle term, by using the FOIL technique, drops out, so we end up with just the first term squared and the last term squared with the subtract sign. When we do the cubes of a binomial, we have u cubed at the beginning, v cubed at the end. We have 3's for the coefficients. Then we go down in descending order, so it goes u squared and u. Then we go up with the v, first power, second power, third power. When we have the negative sign, we get the same answer that we have here, except that the signs alternate. So it'll go positive, negative, positive, negative. Again, if we forget these, we can go over to our calculator. We can use the expand command, and it will give these formulas to us. Let's turn to the next page. So the next page has us work problems out using this technique. So when we use this technique, we write down the formula, then we substitute in for u the 3x, we have the 2, we substitute in for v the 4, so we put the 4 in here and the 4 here, then we multiply the quantity 3x squared, get 9x squared, multiply the constants, get 24x plus 16. When we're doing a cubic, we write down the formula, u cubed, u squared, u, v squared, v cubed, alternate the signs, negative, positive, negative. So then we substitute in that u is 2x, and we substitute in that v is 3. And we go through and put all these in. And then when we do the arithmetic that's involved here, we end up with 8x cubed minus 36x squared plus 54x plus 27. Again, let's take a look at this on our calculator. So when we go back and we square it, we end up with 9x squared plus 24x plus 16. When we cube it, we end up with the same answer that we got when we did it manually. You might notice one other detail. We're now working on example 3, but this is tab 2. What happened was we must have looked at our problem in the middle, and when we inserted the problem into our calculator, we were on 1 and it inserted in the middle. We should go through and switch these two around so that they are in the right order. Let's go ahead and look at our exercise answers here, because we have a radical in the problem and we have 3 terms. So there's a couple of things going on that are a little bit different. So let's go ahead and take a look at this. So we'll follow this link, and it will take us out to our exercise. So again, the special case formula will be u squared minus v squared. So it will be the square root of x squared minus 3y squared. So when we square the square root of x, we get x minus 9y squared. When we have this one, we might notice that this is a special case. The 2x plus y is in both, minus 3 plus 3. So technically, this is u plus v times u minus v, with the u being equal to 2x plus y. So we end up with 2x plus y, the quantity squared, minus 3 squared. So the other way to work this problem would be to take the first times all 3, the second times all 3, and the third times all 3, and then combine things. But if we happen to see that it's a special case, this makes it a little bit easier. Then using our special case formula, we have the first one squared, we have the last one squared, and then we have double the product of these two, plus we have the last 3 squared. Doing this middle part out, we end up with this. If we take a look at our iPad screen, we see that it ends up with x minus 9y squared. If we substitute in a value like -4, it gives us an answer. While there's a warning up here about the domain, okay, of the answer may be larger than the domain of the input, because we can't input in here a -4. But since this simplifies it to this problem, and when we input the -4, it inputs it into here, and we end up with this particular answer. So we have to be careful when you get warnings, because it can lead us to problems. Again, at this point, we're only talking about real numbers. If we go over to our calculator, we can look at what they call imaginary numbers, and we'll take a look at that in a second. So if we input into our calculator 2i minus 3y times 2i plus 3y, it gives us this answer. So what our calculator is doing also with problems like this is working them out with complex numbers. So even though we didn't change the mode, by using I, which is the square root of -1 in here, we can get answers when we're still in the real mode. But if we just put -4, it will tell us it's a non-real answer. So these are the kind of things that we kind of have to watch out for. For the part B answer, we use the expand command, and we see that it turns out to be equal to this. Let's take a look at our calculator a little bit more about the I information. So let's go over to our calculator and hit the scratch pad. Let's clear out what we have in there. Menu 1, 5. Let's put into our calculator control square root -4 equals, oops, let's get outside of the square root, equals square root 4, move outside the square root. Then we're going to go down to the pi key. We're going to move over and put in this I. We're going to press enter to move the I up there. And it says that this is true. So later on, we're going to be dealing with the square roots of negative numbers, which are imaginary numbers. And when we put them together with a plus bi, it will be called the complex numbers. So what we do is we switch when we have a negative square root to this I, which is the square root of -1. And it says that this is true. So again, when we were multiplying stuff out on our iPad screen, we've seen that this was happening. The next thing let's look at, let's go to the square root of 4. Let's move outside here. Let's go to our pi. Let's get our I again. Press enter. And let's set this equal to 2. Go to our pi key again. Get our I. Press enter. Press enter again, and see that this is equal to true. So this is one nice thing about the calculator, is if we want to see if things are equivalent to each other, we can use the Boolean operation with the equal sign. So we can see that this stuff turns out to be equal to 2i. In fact, let's end with one last thing and then we'll end this unit. So let's put in I. So we'll move over, select I. Then we'll hit our squared and press enter, and it's equal to -1. So when you start working with complex numbers, the two most important things that you have to deal with is whenever you see I squared, you need to realize that it's equal to -1. And whenever you see the square root of a negative, before we work the problem out, we have to switch it so the square root is positive and we have the I in the problem.